we are basically got one section left to do in triple integrals. And we are going to look at spherical coordinate system. So if someone was saying to you, when should you use cylindrical coordinates? Isn't the answer if there's a circle or a part of a circle on the XY plane? So when should you use a triple integral with spherical coordinates? You should really use that when the region that you're doing your triple integral over is a sphere or part of a sphere, like a hemisphere or, a quarter of a sphere. I'm not sure what you would call them, but if the whole object, the region, put a word on it. If this region R, right, is a sphere or part of a sphere, then the spherical coordinate system will be helpful. Spheres are notoriously ugly if you leave them in terms of X, Y, and Z. They just are. And the integration that you get from them is pretty much a non-event. You ain't going to be able to do it. So here is my very bad copy of how you tell someone where a point in 3D space is, and in particular this point where my finger is, in terms of spherical coordinates. And there are three numbers. Rho, in some textbooks that's called R, is the distance from the origin to the point. So that's who rho is. The other two are angles. The angle theta is the angle that you make on the XY plane going round the way. And theta is the angle you make with the Z axis coming down the way, like that. So if you tell me that angle, and the distance away from the origin, that is a unique point in 3D space. So that's how you tell me where things are in 3D space. Now, when we did polar, wasn't the X and the Y coordinate very simple? X was r cos theta, Y was r sin theta. Do you notice that when you introduce spherical coordinates, the X is now replaced by this expression and the Y is replaced by that? Do you notice that the main difference is that there's an extra sign phi? Oh, by the way, pronunciations. That guy we know is theta, not theta. Does anybody know what that guy is called?
Isn't it phi?
Oh God, not again, Americans.
Is it phi?
It's phi, yes. Like in phone. Right, it's an F sound that you get when you put PH. And you called it what? Phi? Phi? Like in fee, fi, fo, fum?
Exactly.
No, don't call it that. It's probably the way Americans do it, but don't call it that, right? Just call it phi. And that way, when you go to university, this is me sidetracking. If you're anything like my experience of other universities, less so in Scotland, but true in many other universities, is that when you go to wherever it is you're going, there's a very, very good chance that half your professors are not American. You'll find out your math professor is Polish, or your chemistry professor is German, or your, whatever it is Japanese. America can afford to pay a lot of money. And people like lots of money, so they go and teach in America because they get paid like 5 times what they would get paid back home, right? And for that, you tend to get the best, whatever that means, because of that, right? So you get Nobel Prize winners and everything like that. So you might well go to UW Washington, and there's a fair old chance that half your professors aren't American. So you've got an advantage. You've already seen a guy who talks funny, and you're already used to different ways of saying Z and J and Phi and Theta, right? So you got a heads up. You won't be surprised then if your guy's Polish and he says it a funny way as well. That's drifting, right? Back to this guy. There's X, there's Y, and there's Z. Now, if you want to tell someone the equation of a sphere, X squared plus Y squared plus Z squared equals rho squared. When you do a triple integral, the dv gets replaced by this horrible mess. You're just going to have to write it down and remember it, because there's no logic to why that's what it is. But can you remember when you did the polar, didn't you get an r dr d theta, right? That extra r, right? Can you see when you go spherical, you get a lot more than just an extra rho. You get a rho squared and a sine of I, right? And that's going to be important. Here are some restrictions. Rho must be positive. So you'll never get a rho from rho equals -2 to rho equals 2, right? That ain't happening. It's just like R, right? Starts at 0 and goes somewhere. And phi is only going to be between 0 and pi. And the reason for that is phi starts up vertically at 0, and then you curve down the way and you get to the bottom. And that's enough to do everything. Well, you might think about how about all the stuff, whoops, how about all the stuff over here? Theta takes care of that, because isn't theta in the range 0 to 2 pi? So far, so good, guys. New coordinate system called polar. Really should only, it's a niche market, right? Only use it in situations where there's a, you know, the region that you're integrating over is a sphere or part of a sphere, right? That's the typical ones. There are exceptions to that. Cones can sometimes be used as well. So I'm putting you on mute right now because there was a little background sound that was getting to me. So far, so good. Right. I think I've still got this on. Oh, shooting space. It's worked. Good. Not going to attempt to draw any of these, so I decided to cheat and use the textbook, so you can go and look at it yourself. But here is what a cone looks like. Theta equals C. And as long as C is between 0 and ½ pi, you get a cone that's on the top, right? By the way, that's an infinite cone, right? It goes on forever, right? And if the angle is between pi upon 2 and pi, you get the downwards pointing, right? So upwards pointing cone, downwards pointing cone. I don't know why you would call it half a cone, because it's really a full cone. Well, we already know that. Okay. There's their version in my picture. And can you notice that I've taken a lot of the extra lines out, because I think, isn't that picture just too busy? Right, so that is my version of their picture, right? The one I drew just takes the essence of what you need to know. Now there should be some sphere stuff going there. There's the sphere stuff we already talked about. I think there's a plane one floating around. Is there a plane? Maybe it's on the next page. Ooh. There's some cool 3D stuff. I don't need to do that. Yeah, okay, that's pretty much it. Oh, that's what a question would look like if you try to do it with X's and Y's. Can you see how ridiculously impossible that integral would be? Right, this is basically a sphere being integrated, right? And there's a function. Not really your best friend. So let me stop that share. And let's look at some questions on spherical coordinates. Right, well, one of the tasks that you're going to have to deal with is, you know, you're going to have a triple integral. And this guy here is going to be some function. It could be, for instance, simply just x squared plus y squared plus z squared, right? One of the tasks is, don't you have to turn all the x, y's, and z's into rhos, phi's, and thetas? Great. You would have to do that in polar as well. So here is question 1a. And we're taking a region that looks like that. And we're going to convert that into its spherical coordinate system. That guy is pretty easy to do. What does that whole package become in terms of rho, theta, and phi?
Isn't it rho squared?
Yeah. And why can I then write down just that rho equals phi? Why am I not saying plus or minus phi?
Because it can only be positive.
Right. And if you think about it, isn't all the points who are 5 units away from the origin, doesn't that give you the shell of a sphere? Now, the next one is not pretty, and some questions just aren't. If you don't get anything pretty, right, you just get a random combination of X, Y's, and Z's, then turning that into its polar equivalent really just becomes trying your best to convert everything into rho, phi, and theta, and with a bit of trig, make it as nice as you can. But don't expect rho equals 5 out of this, right? In fact, you'll be amazed at how ugly this is. It's really just messy algebra. Every X gets replaced by that, every Y gets replaced by that, and every Z gets replaced by that. So I'm just going to do substitution, and off we go. And I already know what the answer is because I had to look at it, make sure I didn't get it wrong. Well, that doesn't mean I might still not get it wrong. X squared then is going to be this guy squared. To save one line of working, are you okay with me just squaring it, right? Take away this guy squared. Take away this guy squared. So I guess step one would be replace X, Y, and Z by these 3 expressions. Right, now style points. 3 separate expressions. Can you see anything? Anything that you could do to make it pretty? Yeah.
Check out the d squared.
Okay, so rho squared coming up. Sine squared phi, cos squared theta. Take away sine squared phi, cos squared theta. Take away cos squared theta equals 1.
Could you also take away the cos squared theta? Or phi? No, that's theta.
That's theta, that's theta, and that's theta.
Wouldn't the y be like rho squared sine squared like phi
Oh,
or sine squared?
yeah, no, that's the sine squared. Right, sorry, I interrupted you. What were you saying again?
Like for the y squared part of it, wouldn't it be rho sine squared phi then sine squared theta as well?
Thank you. Yeah.
Thank you.
Which now means the poor cos squared can't be taken out. If I had been correct, you would have been fine. I can still do some more. Less obvious, but I can do some more. Only these 2 terms, but it's worth doing. Can you see anything you could pull out of those 2? Just those 2, not that one.
You can pull out a sine squared from those 2.
Okay. Now, typically that's not a thing you would want to do, but in these situations you have to sometimes break the rules. We're almost done. Does anybody recognize who that guy is?
That would be cosine of 2 theta.
And at this point, can you say we've done the best we can and that's the answer? Now, could I rearrange it as rho squared equals and then take the square root? I guess I could, but there's probably no great advantage to it. So, horrible trig expressions, you just have to live with them. And this is from question 2. Z equals 4x squared plus 4y squared. Z is rho cosine theta. 4 times this guy squared, and this time I'm going to try and make sure that I do it properly. Okay, that's where we are right now. That's Z, that's 4x squared plus that's 4y squared. Right hand side. Anything you can do here? One expression plus another. Anything you can do to make it look pretty.
Out the 4b squared sine squared by.
And that leaves me with what? A cos squared theta plus a sine squared theta. Oh, that was nice, wasn't it? Can you do anything with this guy?
Make it 1.
Looking much nicer, isn't it? We try and take it, if possible, you should try and rewrite it as rho equals. So that's what my goal is going to be, to see if we can make this eventually be rho equals. What could I do next?
Divided by rho.
Normally, that's perfectly correct, and that is exactly what we're going to do. But normally I would say, don't do that. Danger, Will Robinson. Because if rho is equal to 0, won't you have bad things? Right? If 2x was equal to 4x squared, right? Or let's do it different than that. If 2x was equal to 4x, if I divided both sides by x, wouldn't I end up with 2 equals 4? Do you see why it's dangerous to do that? Why am I going to accept it this time? We are looking at a situation where we're talking about something in 3D space. If rho was equal to 0, wouldn't it just be the origin, a point on the origin? It would be the origin. So we're going to assume quite sensibly that rho is never going to be 0, right? And because we know it's not going to be 0, we can do what exactly you said. So yes, I am breaking my rule of don't divide both sides by x because bad things happen, or in this case, yes, but you can do it with rho because you know rho is not 0, is the kind of caveat to that. Okay, keep going. Remember, the goal is rho equals.
I got kind of a weird answer from doing this, but I'll, you know what? I missed the phi. I'm gonna retry that.
You lost all your phi's?
Not all of them. I keep getting it mixed up with theta.
Oh, it must be just, you're right. Okay, tell me what to do next. I want rho on its own.
Would you divide by the sine squared?
And probably a 4 as well while we're at it. Are you comfortable with that, everyone? Right. If you're being a purist, Wouldn't you write that down? Because trig doesn't like fractions. If you can avoid them, you should. And let's have a look. They've decided. What have they decided? I'm looking at the wrong question. Right, I like that one. I was looking at the wrong answer. So if you have to turn the expressions, aren't you going to replace the x with this, replace the y with that, replace any z's with this, and try and use all the trig identities, factoring, combining that you can get away with. And if possible, which it might not always be, write it as row equals. So the next question that we're going to do is a triple integral that's already set up for you. And it's going to be rho squared sine of phi d rho d theta d phi. And the phi is going to go from 0 to pi over 6. And the theta is going to go from 0 to pi over 2. And last but not least, the rho is going to go from 0 to 2. And if you can imagine what that thing looks like, can you imagine somebody got, oh, I don't know what they're called. Do you know those oranges that you get that in little wedges? You know, the chocolate orange?
Yeah, they're just Terry's chocolate orange.
Right. It could well be one slice of that orange, right? You know, it doesn't, it might not look like a sphere, but it's a part of a sphere, even if they look less spherical and more triangular. But that's my best guess. I don't quote me in that. But in a way, I don't need to know how to do that because this is a triple integral. And first question I try and ask myself is it separable? Because if it is, it makes my life 10 times easier. Is this one separable?
Yes.
Tell me, correct. Tell me why. What's the features that it's got that make it okay?
None of our limits are functions, so we can split it up without having to worry about that, I guess.
That's a biggie. You're right. What's the other thing that has to be true? Because you can have this bit okay, but this bit's still not separable. So what kind of makes this separable?
Wouldn't it be the fact that rho squared and sine of phi are separable themselves?
Yes, because you can multiply them, essentially.
Yeah.
I think I've done that the right way. And don't you get 3 answers and off you go and you're done? I'm not going to finish that question. According to them, and I'm just looking at a picture of what this looks like, because one of the questions they ask is, which one of these 4 things is it? Evidently, this shape is like a piece of chocolate oranges. There's 4 versions, only one is true. Now, the next question, I'm going to show you it because it's very visual and I'm no good at drawing, where we have to set up the triple integral. All we're going to set up is the limits of integration, right? We don't need to integrate anything, just what the limits are. And orientation is the thing that always gets me. So bear in mind that I could get this back to front if I'm not careful. This region is basically the top half of a sphere that they've cut the first octant out of, right? So it's like a sphere inside the sphere and the first octant is missing, right? That's what I'm saying. Does that seem reasonable from what you're saying, right? So we have to figure out what the limits of integration are in this thing. And why is it written that way? Oh God, it's so ugly. That integral, and that integral should be together, but it's that big they had to rewrite it on the bottom line. So here goes. What's our guy going to look like? And I think that's a mistake already. No, I take it back. It's not a mistake. Right. This fella here is the row value. Why do... No, he's not. Oh, yes. God, I wish they wouldn't do it in 2 rows. This guy is the row value because isn't that the first variable? And the first variable goes with him. The second variable goes with him, right? And the last variable goes with him. Okay, so that's 4. Would you agree that this is 6? Are we orientated good that way? So far, so good? Right. That basically, if everything else was the full value, right, 0 to pi and 0 to 2 pi, wouldn't we just have a sphere with a hole in the center, a spherical hole, like a hollow sphere, right? That's what it would be. Now it gets a bit trickier. Here we're going to do theta. Now, from this orientation, you've got to imagine looking at the circle from above. And I'm going to leave this for a second and show you what that might look like. And that's why you have to kind of have a 3D brain sometimes. If you imagine what the XY plane looks like, the bit that's missing is here. So what you've got is that guy and that guy, right? Does that make sense? You see the orientation is low. Now, if you are looking at what are the angles that theta should be. Now, theta is starting here and finishing here, right? So the rotation, right? That's theta, right? Would you agree at this point here, theta is pi upon 2, but that they gave us. What's theta going to be by the time it gets to there? And look at the way it's going to turn.
0 or 2 pi?
Yeah, which of those two? Because it's one but not the other. So you're starting here, pi upon 2. You're getting to pi. Now you're at 3/2 pi. And then you're finishing here. So are you comfortable why that's 2 pi? Okay, so that's what goes there. Now, different orientation. This is my reattempt at this shape here. And all I'm really interested in is the phi value. Now, the phi value is the angle that you get with the z-axis. Now, you start at 0, right, which is vertically upwards. And then you turn to the right. So you go like this, which would be what? Pi upon 2. And then all the way down to the bottom would be pi. So the value of phi goes like this. This shape is only on the top half. So at this point here, at this one here, that's phi equals 0, right? So you're measuring a different orientation here, right? Vertical, right? As you turn, don't you stop at pi upon 2. Right, vertical to pi upon 2. Does that make sense? So there's your 3 guys. Let me return back to that answer. And 0 to pi upon 2. Hopefully it'll take pi upon 2. Oh, it did. I've forgotten what our other one was. Oh, to 2 pi and 0.6. And this guy here is just the x. So this is going to be rho sine phi cosine theta. Let's figure out how to do that. I'm pretty sure they're hidden in the Greek letters. So there's Greek, there's your rho. Then you want to do the sine, if phi. Yeah, there's phi. And cosine of theta. And there is theta. Okay, and then the rest goes here and here. And what goes in this box?
Isn't that the square?
Yeah, that's that rho squared. You remember there's an r dr d theta. Well, in cylindrical, it's an r, it's a rho squared sine phi that you have here. So rho squared. Will it take it this way? I'm trying to do shortcuts. Oh, good. Rho squared followed by the sine of phi. That's the question finished, right? Are we good? Right. 90% of your work is going to be setting up these darn integrals, right? Getting the getting the thetas, the phis, and the rhos organized, and then once you do that, you've just got really ugly trig integrals for the most part to do. Any questions so far?
Yeah, how did you get the phi, sine, phi, cosine theta on that one?
Click on this box. Here we go. I'll show you. Are we still on it? We still on the screen?
I can see it now.
Okay, so I'll click over here and do another one then. Greek letter, phi.
Yeah, no, I meant like, how did you know that, like the phi, like sine, like thing? Like, how do you know that that was supposed to?
Oh, that's always there. So let me show you in my notes. That is part of the mechanism that you would use to get an integral. Do you see this guy here? dv is rho squared sine phi d rho d theta d phi. That is part of the puzzle, right? That's what you use when you do.
Yeah, but didn't we put that like at the end with the rho squared sine phi and then like all the other stuff at the end?
Yes. Which is where it is in that question. It looks wonky because it's in two rows, and the guy at the end looks something like this. But that's where that thing went. It went in this box here. They had other boxes where the X, Y, and the Z go. So let me return back to that, because that didn't make sense to me. I knew what I was talking about. Right. Here, this says F. So this is essentially X. This is going to be Y. This is going to be Z.
Okay, that makes sense.
Finish it. It's just clunky. I guess they could have made it smaller, but then you wouldn't be able to read it if they put it on one line. So you're fighting two different issues if you try and do that. Okay. So let's do one from scratch. We are being asked to integrate in question 5. A triple integral over some region B for ball, I guess. X squared plus Y squared plus Z squared all squared dv. And oh, they are so nice to us. B is a ball. I don't know why they're calling it a ball. Can we call it a sphere? I guess a ball is I know. Why'd they call it a ball? Isn't a sphere just a ball? I mean, I don't know why. Anyway, it's a sphere, and its radius is 1. So, rho is 0 to 1. Right? If the radius was 10, it'd be 0 to 10. Phi, since it's an entire sphere, goes from 0 to some number. And theta, since it's an entire sphere, goes from 0 to what number? Can anybody, I'm trying, yeah, I hit it. What does phi range from if it's an entire sphere?
Zero
Yes.
to pi, right?
Yeah, and then 2 pi for the other one. So our guy is going to be in any order you like, because they're all numbers. What order are we doing them in? We're doing rho equals 0 to rho equals 1. Then we're going to do theta equals 0 to theta equals 2 pi. We're going to do phi equals 0 to phi equals pi. What will x squared plus y squared plus z squared get replaced by? In terms of rho, theta, and phi, what do you replace that guy by?
Wouldn't it be rho squared and then squared again?
So rho to the 4. Great. And won't the dv get replaced by this fella, which is actually another rho squared sine phi d rho d theta d phi? Are we good so far? Would you agree this is variable separable, right? Can we separate this thing out? And there's the phi. And he's going to get that guy. This has happened before, but it's worth asking. There isn't any mention of theta here. What do I put where my finger is? I don't leave it blank. What do I do here?
1.
It's always 1, right? And then combine the rows, so it's basically going to be rho equals 0 to rho equals 1 of rho to the 6 d rho. I think it's probably even more important now, isn't it, to do that little bit that they don't do in textbooks, because it's going to be very, very easy to switch these two guys around and think that that's a theta and the other's a phi, and just make your life a misery. Are we good with that?
Can I see the sheet one more time, please?
Sure. Here we go. This will be the last one for today. Okay, ready to move on? Here is a triple integral, y squared z squared dv. We're looking for a region that's above this fella and below this fella. And the above part here is more important than this piece. This piece here is almost, well, what's the word I'm looking for? You don't do much with it. How about that? Now, if you're above a cone, right, you know, a cone that, one of those guys. I know I only did it fleetingly, but if you want this cone and it's that fella, you're going to start at the vertical, right? Which is, you're going to start at 0 and you're going to finish at pi upon 3. So if you want a cone to look like that guy, don't you need phi to be 0 to pi upon 3? Because what that does is it fills in the cone. So it's not just the surface of the cone, it's including the piece inside it, right? Now, what about a sphere of below that? Essentially, you're doing that because what you're going to have here is, and I'm not even going to try and draw it because I'm not sure I know what it looks like exactly. But if I put mother axis, can you imagine there's a sphere going on inside this thing? So those two things are interacting. Otherwise, that cone goes on forever, right? And that's this guy. Now, there's no indication, but I think it it's pretty obvious what the value of theta should be in this story. Anybody want to have a shot at it? What are the range of theta in this cone meeting up with sphere interacting thing?
0 and pi over 2.
Ooh. Interesting.
Guess not.
No, but I'm trying to think of what you're thinking here. Is it because you're seeing the top of the shape kind of thing? Is that what you're thinking?
That's what I
Right,
was.
right. If you visualize it from the top looking down, wouldn't you see a sphere? Not a sphere, wouldn't you see a circle? Now, the phi is the top half that you're talking about here, Christian, makes sense, but is it the phi value making that part happen? Right? So the phi is what's keeping the top part going, right? So it's kind of inbuilt, but maybe less obvious. Right. The only time this would change would be if I took this shape and then like cut it down the middle and threw away the left-hand side, right? And in which case I'd have half a circle that might go 0 to pi, for instance, right? Or if I said in the first octant, wouldn't that go 0 to pi upon 2, right? God, I hope they never do that. That's bad enough. Now I'm going to work on just this guy right now. Otherwise, I end up having to write lots and lots of integrals all over the time just to figure out what this is as a nice answer. Has anybody got a good memory? Going to move the page. Anybody want to tell me what y is before I turn the page and show you?
So you're talking about phi squared, sine pi, or phi, sine theta.
Darn close.
No, close.
Close. That's good.
He meant the root of that and then squared, right?
Yeah, what she said.
Well, she said.
Gotcha.
Right. So if you take this guy and, oh, you got a sine. Oh, yeah. Try that again. I'm looking at the wrong one. You were right and I was wrong. There we go. And Z is this guy. And while we're at it, why don't we do the dv part, which means I add in another rho squared sine phi and the stuff I don't have room for. So all of this is one horrible multiplication. So I'm going to get a rho to the 6. I'm going to get a sine squared phi, and I'm going to get a sine squared theta, and I'm going to get a cos squared theta, and then I can put in the d rho, d phi, d theta stuff, right? Okay, we put the limits of integration, which we already know, with this guy, and we get, in no particular order, phi goes from 0 to pi upon 3. Rho goes from 0 to 1. Theta equals 0 to 2 pi. You know I'm allowed to get away with that because they're all numbers and you can switch them around any way you like, right? And then we have a rho to the 6, a sine squared phi, and then a hopefully sine squared cos squared theta with some stuff. Let's split them up. That's going to go from 0 to pi upon 3. The rho is going to go from 0 to 1, rho to the 6. And the last one, theta is going to go from 0 to 2 pi. And it's going to be sine squared theta, cos squared theta, d theta. So it does separate. I think it's best to maybe take each one separately. At least I'll set it up for you because there's a lot of work involved. I need to integrate that guy, which means you need to think back to Calc 2. How would you rewrite sine squared so it's in a format that allows you to integrate? And it's not a U sub and it's not an integration by parts. It's an algebra thing. It's a trig identity. Okay, I'll start it for you. It's a half.
Is it 1 minus sine?
1 minus, yes,
Oh,
Sine
cosine
of 2.
cosine.
squared theta.
Mhm.
Jeez.
2 theta.
2 theta.
Yeah, yeah, that one. Right. Can I say ugly but doable now, right? Only for completeness sake.
Is
When
it
that one-
theta? Or is it
It'll be phi to be consistent with that variable. And that one is pretty much easy to do, right? But for completeness sake, I've done it. Now, the worst one of the three. How are you going to do this guy? Come on, I'm getting old here. Older. I'm already old. Every one of these minutes is another minute in my life I'm not getting back. So come on, do something useful with my time. Have a shot in the dark and get it wildly wrong, but at least you're trying.
Use the double angle formula to sine theta, cosine theta, and then use it twice.
Oh, interesting. So a half, oops, it'll have to be a quarter. 2 sine theta cosine theta squared. And that is a quarter of the sine of 2 theta squared. I like it. That'll work. That's not the way I was going to do it originally, but that'll work. Any takers on the next step? Because they're actually just one more step and it's done. Stick the quarter out there. If you don't like the way that's written, how about calling it sine squared of 2 theta? Does that help? We've used this 5 minutes ago. Sine squared 2 theta can be written as something. Just like sine squared theta could be written like something. Here's the start.
1 minus cosine 2 theta.
Is it going to be 2 this time? It was 2 the last time. But
Oh.
since I'm starting with 2 theta, what do we get this time?
4.
There, and off you go. Ugly as heck, but doable. Setting up is quite difficult. Making it look pretty, right? Variable, separable, whatever. Each one that you get, you know, you have to bring in some Calc 2 tricks from the past. And that is us.